Hello everyone. In the today's video, we will discuss one of the type of the decoder, that is 2 to 4 line decoder. This figure shows 2:4 decoder in which two inputs are there, which are represented by capital A and capital B, and four outputs are there represented by Y0, Y1, Y2 and Y3. There will be one enable pin. This will be act as a switch for the 2:4 decoder. When enable pin is equal to 0, this decoder is going to be disabled. In that moment, it will produces all the outputs as 0, even if you apply any of the input. When enable pin is equal to 1, this decoder works normally and it converts these two inputs into four possible outputs. And remember, among these four possible outputs, only one output will get active at a time based on the input combination. Let us see the truth table of a decoder. In this truth table, we will have one enable pin column, two inputs capital A and capital B, and four outputs are there, Y3, Y2, Y1 and Y0. The enable pin will have two values, 0 and 1. Let us take first 0. When enable pin is equal to 0, all the outputs will shown as 0 even if you apply the inputs. Whatever the inputs you will apply, if enable pin is 0, then all the outputs will shown as 0 only. In the second case, when enable pin is 1, there will be two inputs here which will have four possible input combinations. Those are 0 0, 0 1, 1 0, 1 1. In these four combinations, all the enable pin is 1. And coming to the first combination of input, when capital A and capital B are 0 and 0, based on this input combination 0 and 0, Y0 will get active. Y0 output pin will get active and remaining three outputs will be 0. In the second input combination, that is 0 and 1, the Y1 pin will get active. Based on the input combination 0 1, 0 1 is equal to 1, so Y1 will get active and remaining three output pins will be 0. Next combination is when A is equal to 1, B is equal to 0. This AB is equal to 1 0. In this case, Y2 will get active, Y2 output will get active and remaining output pins will be 0. Last input combination is double 1. When A is equal to 1, B is equal to 1, though Y3 will get active and remaining all the outputs will be 0. So this is the operation of 2 to 4 line decoder. Remember here one point, when based on the input combinations among these four possible outputs, only one output will get active at a time. So that's what the decoder represents. Next one, let us see the logic diagram of 2 to 4 line decoder. Here I have taken one input capital A. For this input, I have applied one inverter. So here on this line, it will represent capital A bar, complement of capital A. Next line input is B. For this B, I have connected one inverter. On this line, the B complement is going to be there. And one enable pin is also there. That enable pin will be 1. When enable pin is equal to 0, all the outputs will be shown as 0 only. So when enable pin is equal to 1, all the outputs will get active. So now see here, in these four output columns, I have taken in each output column will have 1. When Y0 is equal to 1, the capital A and capital B are 0 and 0. This represent one minterm. So for all the four output lines, there will be one minterm is there. That minterm is going to be represented by using a AND gate. So here, as we will have four possible input combinations, that means four possible minterms are there. So that's why we have taken four AND gates here. For the first AND gate, the inputs are A bar and B bar, and third input is enable pin, that is active 1. At that time, Y0 will be equal to A bar B bar. For the second AND gate, the inputs are capital A bar and B. So A bar and B, which represent this column, this row. In this case, Y1 will get active. So Y1 is equal to A bar into B. For the next AND gate, inputs are A and B bar. When A is 1, B bar is 0. So, and third input is enable pin. In that case, Y2 will get active. That will gives A into B bar combination. For the last AND gate, the inputs are capital A and B. So the third input is enable. So Y3 will gives A into B. This is all about the 2 to 4 line decoder. Thank you.